Hey guys, welcome back to another Algebra 1 lesson. Today we're going to begin with writing equations. So let's just get right into it. In this problem it says that Garrett counted paper products. The small paper cups come in sleeves inside of a cardboard case. He counted 6 cases and 12 sleeves. So I went ahead and drew out the picture for us. We've got the 6 cases and then we've got the 12 sleeves. We can check that and we are correct. So part 2 then says you're not given a number of sleeves of cups in each case. We don't know how many sleeves are in there. So how could we represent something that we don't know? Well, typically speaking, we let an unknown be represented by a variable. A variable, remember, is just a letter that represents an unknown value. So we let it be represented with a variable. And then we're going to keep moving on here. It says, if there are n sleeves, that's our variable that we're letting represent our unknown amount. There are n sleeves of cups in each case. Then how many sleeves would there be in the 6 cases that Garrett counted? Well, we know that then there's 6 cases, n in each case. That's the same as saying 6 times n. So there are 12 sleeves of cups outside of the cases. So how would we represent that? Well, we take how many are in the case, 6n, because we don't know how many exactly, and we add the 12 that we do know that are outside of there to it, and that gives us this expression. Notice it says this is an expression. The next part says, we know that there are 162 sleeves of cups. That's how many he counted total. So we're going to use 162 and this expression up here to write an equation to represent the situation. So we know there's a total of 162. And we know that they found that by counting how many was in each of the 6 cases and adding the 12 outside the case to it. So now we went from having an expression up here to an equation down here. So I want you to think about that for a second. What is the difference here between this expression and this equation? In an expression, there is no equal sign, but in an equation, we have an equal sign. Think about the word equation, E-Q-U-A at the beginning. Think about the word equal, E-Q-U-A at the beginning. In an equation, there is an equal sign. In an expression, there is not. Then the last part of this says, reread the problem. Do your picture and your equation correctly represent the situation? So let's think about it. Said there were 162 sleeves of cups in all. There were 6 cases, and there were 12 sleeves outside. So we said 6 times the number of sleeves inside plus 12 equals a total of 162. So yes, that they do match. So again, I want to emphasize the fact that an expression does not contain an equal sign. This is an expression, 4x plus 2. 18 is an expression. It becomes an equation when we insert this equal sign. So there are some steps for writing an equation that we should think about. This first step is to identify each unknown and assign a variable to it, just like we did in the previous problem. We said we're going to let n represent the number of sleeves inside of each box. Then we identify what is given and its relationship to that. Well, we knew there were 6 cases. We also knew that there were 12 sleeves outside. We also knew that there was 162 sleeves altogether. We used all of that information then to write the sentence as an equation. So let's begin with example 1. If you're following along in your workbook, I am at the bottom of page 65. It says, write an equation for each sentence. A number plus 2 is 8. Some number, we don't know what that number is, so we've got to let it be represented by a variable. We're going to let n equal the number. Plus 2 is 8. Well, plus 2, all we do is write plus 2. We're adding 2 to that unknown number. And then the fact that it says is 8. The word is means equals. It equals 8. A number plus 2 equals 8. You can exchange is and equals, and it doesn't change the meaning of our sentence. So now we know that the equation is n plus 2 equals 8. 20 minus the quotient. It's important to know, what does the word quotient mean? The quotient is the answer to a division problem. So 20 minus this division problem of 7 and x, so 7 goes on top, x goes on the bottom, is the same as, well, we know the same as could be exchanged with the word equals, is equal to twice x. So I have x 2 times. So let's look at it. 20 minus the quotient of 7 and x, that's the 7 over x, is the same as, or is equal to, twice x, 2 times x. So now we have our equation written here for us. Let's look at another example. Writing an equation says, Life Online. Of 799 teens surveyed about what they do online, some use a social network. Of those on a social network, 430 say people their age are mostly kind online, and the remaining 193 do not. So write an equation to find the number of teens surveyed who are not on a social network. So there are 799 teens surveyed. 430 say people are mostly kind, and the remaining 193 do not. So first we've got to identify each unknown and assign a variable to it. Read the problem. What are we asked to find? We're wanting to find the number of teens surveyed who are not on a social network. So first we need to identify the unknown. We're going to let n equal the number of teens surveyed who, since we're looking for those who are not on a social network, we're going to choose are not. Next, we need to identify what is given to us and what is their relationship to the problem. So how many teens said 799 teens surveyed, 430 say people their age are kind, 193 do not. So how many teens were surveyed? 799. Some of the number of teens use a social network. Of those on a social network, say a certain number of those say that people their age are mostly kind. So how many people said that? 430. And 193 do not. So how are the givens related? Well, the group of 799, that's the total, was surveyed. 430 and 193 make up the ones that are on the social network. Therefore, the rest are not on the social network. So now we need to write the sentence as an equation. We group the ones that are on a social network, the 430 and the 193, plus n, those who are not on the social network, added together equals a total of 799 surveyed. So is there only one equation that represents this situation? Not necessarily. We could change the order a little bit, right? But ultimately it is going to be the same equation. We could go ahead and simplify. We could say in one step, well, 430 and 193 is a total of whatever, have that total plus n equals 799. So I could see either argument saying that there's only one equation that represents a situation, because if I simplify it, it's still this equation. It's just this equation then simplified. Or I could see you saying, well, I could write it in a different order and have a different equation. It would be a different equation, but it's still ultimately the same. We're just maybe changing the order or simplifying a little bit. So I could see both sides of that argument. Example 3, we're going to write an equation with multiple variables. So translate the sentence into a formula. The perimeter, we all know how to find perimeter, right? It's when we add all the sides up together, that gives me the perimeter of a figure. Think about putting a fence around your farm, or putting baseboard around the room. All of those things are perimeter. So the perimeter of a rectangle is twice the sum of the length and the width. So you can apply the same steps to write an equation even if there are multiple variables. So this time we don't know the length, we don't know the width, but we do know that the area, or the perimeter, is going to be twice, if it's thinking about a rectangle especially, twice the length, twice the width. So let's look at this. We can assign the variables. P equals perimeter, L equals length, W equals width. So if it's twice the sum of the length and the width, we do 2 times the sum of the length and the width, and we know that this is our perimeter formula for a rectangle or a square. Let's look at interpreting equations. When you're given an equation, it's often helpful to interpret the expression in the equation. This process helps you as you solve the equation and as you interpret solutions in real-life situations. So look for the relationship in equation by interpreting each part of the expressions in the equation. As you interpret an equation that represents a real-life situation, consider that the equation may be viewed as a constraint in the situation. What is a constraint, you ask? Well, in mathematics, a constraint is a condition that a solution must satisfy. These conditions limit the number of possible solutions. The solutions of an equation must meet the constraints of the problem. So let's think about this. For example, if I'm talking about, running a race. I want to run my race in a certain amount of time. Okay, is that ever going to deal with negatives? No, there should not be any kind of a negative in that answer because times aren't negative, distance isn't negative. Let's think about if I throw a ball in the air and I'm wanting to know after how many seconds does the ball hit the ground? Well, again, is it ever going to be a negative value? No. If I'm looking at the relationship of the height of the ball in comparison to how much time has passed, the height of the ball could never be negative. The time could never be negative because we're talking about a real world situation here. Now, if I'm talking about money, I could have negative values. Maybe I'm talking about how much money I have in my bank account over time. If I overspend, then I'm going to have a negative amount of money in my bank account. So sometimes negatives do make sense, but in a lot of real world situations, especially when I'm talking about distance traveled or time, taking how much time something takes, negatives do not make sense. So that's our constraint, would be the x-axis and the y-axis, because we don't want to go below those. We don't want to go to the left and have negatives, and we don't want to go below and have negatives. So let's look at some problems here. Writing a sentence for an equation. Examine and write a word phrase for each term to write a sentence. Move through the slides to see how each part of the equation can be written. And there's not one exact way to word this. Some people might look at this and say 2z minus 1 equals 5. Somebody else might say 2z subtract 1 is 5. Somebody else might say the product in 2 and z subtracted by 1 is equal to 5. There's a lot of different ways that we can look at this. But the important thing to know is that this first term is multiplication. So if we want to say the product of 2 and z, or if we want to say 2 times z, or if we want to say twice z, it doesn't really matter as long as we are implicating that it is multiplication. Then we can say minus 1, less 1, subtract 1, decreased by 1. Doesn't really matter. There's a bunch of different ways that we can say that. And then we can say equals 5, is 5. And when we're writing these words, because they're constants, we just write the word 1 and 5. Write it out. So we've got is, equals, is the same as, is equivalent to. Doesn't matter how we say it, as long as we're implying that this is equals. And then last of all, of course, we've got the 5. So we've got 2 times z, or 2z minus 1 equals 5. 2 times z less 1 is 5. 2 times z subtract 1 is the same as 5. Any of these are possibilities. Okay, example 5, write a sentence for an equation with grouping symbols. How do we show those grouping symbols? Well, it's important to be clear about where the grouping symbols appear. So as we move through the slides, we're going to see how each part can be written. We've got 3. The parentheses tell us that 3 is being times by that whole group of things. So the parentheses tells us that 3 is 3 times the expression there in the parentheses. So the way that we write parentheses, we don't say 3 parentheses y plus 1 end parentheses. I hear that a lot. Instead, we say the quantity. The quantity implies that everything that I say after that's going to be grouped together. It's this quantity. So we've got 3 times this quantity, and the quantity is y plus 1, or we could say the sum of y and 1, is or is equal to 12. It's the same as 12. It equals 12. It is 12, however you want to put it. So putting it all together, 3 times the quantity, y plus 1, is 12. Or 3 times the quantity of 1 more than y is 12. I don't know. There's several different ways that you could say that. All right, last example, interpreting an equation. Given an equation, you can relate the equation to the situation it represents to put the quantities in context. Think of the equation as representing the constraint on the quantities. So write a sentence for the formula for the surface area of a rectangular prism. When we know to find the surface area, we have to find the area of each of the sides and add them all together. Or we can say 2 times the length times the width. That's going to give us the bottom and the top. 2 times length times width. Plus 2 times length times height. If I do the length times height, that's the front and the back of the box. And then 2 times the width and the height. That's the sides. We add all of those together. So we've got the surface area is equal to 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. From the equation, we can see that the surface area of a rectangular prism depends on length, width,